Okay, so free force is 15I plus J newtons, 5QI minus PJ newtons, and so on, where P and Q are constants, act on a particle. Now, given that the particle is in equilibrium, in other words, this means that the resultant forces are equal to 0, find the value of P and value Q. So, okay, all this means that we need to add all these forces, let's call it F1, F2, F3, and they all sum up to 0. So the key idea here is to realize that we can work in I's and J's. So if we're going to sum up each force, we can say that if we're working in I's, then we can say that 15 plus 5Q minus 3P must result to 0I, correct? And as for the J's, we can say that first one is literally 1J, so 1 minus P minus QJ must result to 0. So these are the two equations. So in fact, these are simultaneous equations. Now to make our life super easy, well, let's just do what we do for simultaneous equations and just find a common coefficient. So let's multiply the second equation by 5 so we can eliminate the, it's actually a different order. Let's multiply the second equation by 3 actually, so we can eliminate the 3p. So doing that, we should have 3 here, 3p and 3q. Now, what I could do here, I got minus 3p minus 3p. I could subtract these completely. So you could do it various ways. You could use simultaneous equations or, yeah, up to you. So let's have a look. So we've got 15 take away 3. We should get 12. Now 5q minus 3q will give us plus 8q. And of course, minus 3p take away minus 3p is nothing. And 0 take away 0 is 0. Now just solving this one, subtracting 12 and dividing by 8, so it'll be minus 12 over 8. This should simply reduce to, I mean, you could always use a calculator like I do, because honestly, it's easier. We should get simply minus 1.5. And lastly, now to find P, well, I would just go back and use the second equation. So we initially had 1 minus P minus Q equals 0. So effectively, plusing P across, P equals 1 minus Q. So it'll be 1 minus 1.5, and you should get 2.5. So P would be 2.5.